Okay, so what I have here is the answer key to the study guide. I'm going to go through it. It's already completed, so you're not going to actually watch me work out the problems, but I'm going to talk through them and hopefully clear up some questions you might have so that you are ready for your exam. Remember, West kids, you'll be taking yours on Thursday, and Miller kids, you'll be taking yours on Friday. Okay, so this first question should look familiar. It's just what we got done doing. So if you look at number 1, it says, does it represent a function? Well, yes, it does, because I could do the vertical line test, right? No x values repeat. All is good there. Between what times is the graph increasing and linear? So I'm looking for an increasing straight line. So when I go across here, I see right here between 6 and 8 minutes, or 6 and 8 seconds, it is increasing and a straight line. So that would be my answer there. Between what times is the graph decreasing at a constant rate? So I'm looking for a straight line decreasing, and I see right here between 14 and 16 minutes. Excuse me, 14 and 16 seconds. Between what time is the rate of change on the graph not constant? So where do I see a curve? Well, that's going to be here between 0 and 6 seconds. Provide a possible explanation for this appearance of the graph between the 14th and 20th seconds. Okay, so I'm talking about from here to here. So what could be happening is the boat is slowing down and then stays at a constant speed, right? So maybe there was some traffic on the lake. Maybe they were slowing down they have little kids on an inner tube in the back, and they slow down for the little kids, and then they stay at a constant speed for the little kids. I don't know. Okay. And then according to the graph, what are the maximum and minimum values? So our maximum could be any of these right here, 8:45, 10:45, 12, any of those seconds when the speed is at 45 miles per hour. Our minimum would be down here where it is at 0, right? It's starting out at 5 miles per hour. So I'm going to zoom out and pause for a second. So if you want to take a quick gander at this, let me try to, I guess I'll just zoom in on the answers down here so you can get a look at that. Okay, if you need to pause your screen, you can. And then we'll move on to page 2. All right, page 2, we're talking exponents, everybody's favorite. Okay, so remember, when you are multiplying that has the same base, you add the exponents. So when I add up -5, 15, and -12, I get -2. I can't leave it as a negative. Remember, that's a big no-no. So I have to change it into 1 over 4 squared when now that 2 is positive. Right? So those negative exponents, we spent quite a bit of time on that. For number 8, when you're dividing and they have the same base, you subtract. So 4 minus 11 gives me -7. Again, can't leave it negative, so I have to change it into that 1 over 7 to the 7th power. That 7 is now positive. Down here, power to a power, we multiply those values. So -5 times 3 gives me -15. Can't leave it like that, still have to transform it, so it's 1 over 8 to the positive 15th power. And then number 10, this is where, pretend like there's a little secret 1 hiding there. So I have to distribute this 2, so 2 times 1 is 2, 2 times -5 is -10. 1 squared is 1, right, because 1 times 1 is 1, and I still have that 12 to the -10. This is where, up here, I moved the negative to the denominator, made it positive. Remember, here I move it to the numerator. So you can think of it as being 12 to the 10 over 1, right? And then I just get rid of the 1. That looks like a 0, doesn't it? 12 to the 10 over 1. And then, of course, I just get rid of that 1, and I have 12 to the 10th power. Because, again, we cannot have those negatives. We have to force them either up to the numerator or down to the denominator. Number 11. This is where we have to find what could x be, so that when I multiply these, because that's what you do on that rule, I would get 24. Well, x has to be 6 because 4 times 6 is 24. Similarly, I need to make this so that I was forced to do 1 over 6 to the 3rd. So this has to be an 8 because 5 minus 8 would give me -3. -3 would then be forced to the denominator. So that's how you get x equals 8 for number 12. Number 13. Again, I'm going to add these, and it wants me to leave them as a number, no exponent. So that's why I actually did the 9 times 9 and gave me 81, because that's what that squared means. -3 plus 5 is 2. So that's how I got 81. Here I was forced to put the 3 squared in the denominator. 3 times 3 equals 9, so that's how I got 1 over 9. Excuse me, end of the day, I can't stop yawning. Okay, so this is what we also just did, where you guys have to sketch the function. So I'm going to read what it says, and I'm going to point to what I did here. So it says, Benji biked at a constant rate for 3 minutes until he was 3,000 feet away from his house. Notice here that my y values are distance from home. Okay, so for 3 minutes, he's biking, he gets 3,000 feet away from his house. He had to stop due to a traffic jam, so he waited for a minute. So this shows no movement, but he's just sitting there for a minute. Still 3,000 feet from his house. He realized he forgot his phone, so he biked back to his house. Took him a couple minutes. He's in a hurry, right? He quickly goes in, gets out, and finally he bikes the entire way back to the friend's house and arrived 4 minutes later, which was 5,000 feet away. There's our 4 minutes. If I were to ask you how far did he actually travel, well, you could do 3,000 plus 3,000 plus 5,000, and that would tell us he went 11,000. That's not one of the questions. I just, have to throw things at you. Okay, equations. Everybody's favorite after exponents. All right, so we have fractions. Our strategy has been to clear fractions, so I found the common denominator of 6. I multiplied everything times 6 except what's in parentheses. Remember, that's off limits. So 2/3 times 6 over 1 gives me 12 over 3. 1/6 times 6 over 1 gives me 6 over 6. And 3/2 times 6 over 1 gives me 18 over 2. Then I can simplify. 12 divided by 3 is 4. 6 divided by 6 is 1. 18 divided by 2 is 9. Now I have a beautiful multi-step equation with no fractions. So I distributed. I combined my like terms, inverse operations, and then don't forget to simplify. Over here, we just have some distributive property. I have to combine like terms. 6x minus x gives me 5x on this side. Remember, we don't do inverse operations unless we go over this wall of equality. And then I have my two-stepper. I subtract the 15, divide by 5, x equals -1. Very similar over here, number 18, distribute the 6. Combine my like terms, 6x minus 3x gives me 3x over here. Bring down the -30, add the 30, divide by 3, x equals 14. Number 19 is slightly different, right? I'm going to combine my like terms. 8 plus 5 on the left gives me 8x. And then 20 plus 4 gives me 24. Some of you might have noticed right here you had 8x plus 24 equals 8x plus 24. And maybe you stopped and said, I know that. It's infinitely many solutions because it's the same thing on both sides. But if you subtracted the 8x from both sides and ended up with just 24 equals 24, that should have been your signal that any value will work. That's why it's infinitely many solutions. Down here, number 20. Hopefully you remembered to distribute that secret hiding 1 right there. So you distribute the -1 first, so we get 3 minus 2x plus 5, because a -1 times a -5 gives me a +5, equals a 2x plus 6. Combine my like terms. 3 plus 5 gives me the 8, minus 2x equals 2x plus 6. Add 2x to this side, subtract 6, you end up with 1/2 when you simplify. I'm sure some of you got 2 because your brains just think 4, 2, 2. But really, 2 divided by 4 is 1/2, right? Right. And then number 21 is exactly the opposite of number 19, where when you distribute, you end up with 16x minus 24 equals 16x minus 32. Some of you, again, might have been like, hey, I can't take 24 away from something and make it exactly equal 32 away from it. But if you went ahead and subtracted the 16x, you would have ended up with -24 equals -32, which is not true. It's a big fat nope. So your answer is no solution. All right, next page. We've got these people running this Spartan race. This may have been exactly one we did before. I can't remember. But either way, your job is to convert their hours into minutes and find their times. So I'm just going to leave this right here. 2.5 hours was 150 minutes. Brandon needed 15% more, so I took 150 times 0.15 and added that to get Brandon's time. Cecil only needed 80% of Brandon's time, so 172.5 times 0.8 gave me Cecil's time. I didn't have to do any adding or subtracting. And then they just told us that David's time was 3.25 hours. A fourth of an hour happens to be 15 minutes, so 180 minutes plus 15, add them all up, you get 655.5 minutes. All right, now we've got some sale items. Okay, Brianna purchased a pair of shoes. They're 25% off, so that's what I did first. I took 70 times 0.25 and then subtracted that. So I knew that the 25% off was going to get her down to $52.50. She also has a coupon for $10 off. So I'm going to take $10 off of that $52.50. Final cost of the shoes, $42.50. Not bad. Maybe it was on, the day after Thanksgiving or something. Okay, inequalities. Remember, you solve these exactly like you would solve equations, except we just have an inequality symbol. Distribute the 5. Now I've got a two-stepper. Open circle because it's just less than, and less than goes to the left, right? Because the arrow here for my inequality goes that way. Number 25, I have to combine my like terms, so 3x minus 5x gives me negative 2x, and then 5 plus 2 gives me 7. So then I added 2x over here. So I have the plus 8. I don't know if you can see that very clearly. And then I subtracted 7, and then I simplified, and I got negative 5 over 4 is greater than or equal to x. And then you guys know how I like to rewrite it so that x is on the left. So this is the exact same thing as this. It just has the x on the opposite side, but it still means that this is greater and this is less. I have a closed circle down here where I have my graph, and it goes to the left because in this situation, the arrow points to the left. See guys, this isn't so bad. All right, now we have somebody making t-shirts. They charge $25 and then $12.75 for each shirt you print. The math club decided to design and t-shirts to promote their club. This was their price. How many shirts did they purchase? Okay, so we're going to use X as the number of shirts. Here's my equation. $216 is what they paid for, $12.75 per shirt plus the $25 fee just for creating the shirt. So when you solve it, you would subtract the 25 over here across our wall of equality, divide by 12.75 to get x by itself, and you get 15, and that means they sold 15 t-shirts for the math club. Rational and irrational. Okay, this is back to like the first week of school. All right, so rational numbers, remember, can be written as a fraction. Irrational numbers cannot. So for example, square root of 144 is 12. 12 can be written as 12 over 1. It's rational. Square root of 95. This is not a perfect square, so that should be your signal that this is going to be a crazy number, and we get irrational. For this one, you just simplify the 6 and the 49. So square root of 36 is 6. Square root of 49 is 7. That clearly is a fraction. It's rational. Any decimal value that has this dot, dot, dot here, that should be your clue that it's kind of crazy and random. So that tells you it's irrational. If the decimal just stops, this means it's terminating. That is rational. Down here, you had to decide where would these irrational values fall between which two values. Okay, so 119 is going to be between square root of 10 and square root of 11, or square root of 100 and square root of 121, because that's 10 and 11, right? So we know we're going to choose either A or B, A or D. And then 119 is really close to 121, so that's going to be on the higher end of that window there. Square root of 72 is between square root of 64 and square root of 81. Happens to be closer to 64 than 81, right? The number 72 is. So that's going to be between 8 and 8.5 on that window. 78 is closer to 81, so if I'm putting it between square root of 64 and square root of 81, that's between 8 and 9, but it's going to be really close to the 9, so that's why I chose B. And then square root of 103 comes back to that between 10 and 11, and that's going to be real close to 10 because square root of 100 is 10. So that's how I got A for number 31. And then I had to put these on the number line, right? So I went through and just put square root of 9, square root of 16, square root of 25, so that when I'm placing them, square root of 11 is going to be between 3 and 4, right? But 11 happens to be closer to the number 9 than the number 16, so that's why I put A here. Square root of 23 is going to be between 4 and 5, and the number 23 happens to be closer to the number 25, so that's why I put B over here. Square root of 21 is also closer to 25, but it's further away than 23, so that's why C is here, but on this side. And then square root of 8, 8 is really close to 9, so D is going to be right here before square root of 9. So that's how we estimated those values. All right. We've got 2 rival TV providers. We've got different ways to pay for them. So we have to set them equal to each other. X is going to be number of months. So we set provider A here equal to provider B. One of them charges more to install but less per month. And one of them charges nothing to install but more per month. So when would they cost the same amount? So when you work this out, you get to 7.5 months. I've had many a debate over this. I don't think you can just pay for half a month of cable, but some people think you can. So we'll just say 7.5 months. My answer would be 8 because you can't pay for just like 7 isn't going to cut it, and 8 is when you would be like it would make a difference. So I don't know. I'll accept 7.5. I promise on the quiz, or excuse me, on the exam, it'll be more. It will be more clear to tell which way your answer should go. And that's it. That's the whole study guide. See, that wasn't so bad. You guys are ready. We've done a lot this semester. You've worked really hard. All of it's in your brain. You just have to be ready to use it on Thursday or Friday. Of course, if you have any questions, you can email me or talk to me before you take the exam that day. All right. Thanks, guys. See you soon.